Okay, so we're going to start with this example. Express the area of the region as a definite integral. So it's not actually asking us to calculate the area, it wants us to express the area. But in this case, they're giving us a figure to work with. So first thing we're going to do is remember that area is equal to f of x dx. So basically we want to write this in terms of f of x dx. Now f of x means the same thing as what? Y equals. So is this in y equals format? No, so you need to do a little bit of algebra and write it in y equals format first. Okay, so we solved this thing for y equals, and now we can plug in y for the f of x. So our area is going to be, what's our lower limit and what's the upper limit? Lower limit is at the x value of what? -1. It looks like -1. And what about the right limit to be at 3? And then this one they're going to give you the figure, so you determine your bounds, lower limit, and this one's your upper limit. And our f of x is now 3/4 x plus 11/4, and then we have dx. And that's it. Now they didn't ask us to evaluate the area, so just express the area as a definite integral. So at this point, we're done. Later, we're going to actually calculate some out, but right now we're just practicing. Okay, so we're going to look at another example of this. Express the area as a definite integral. Basically the same instructions as the last problem. They give us our figure. This is our formula. This is the format we wanted in. Now we need to solve for y equals. So let's work on the algebra on that. Okay, so first of all, if we just get y by itself, we would have y squared is equal to, let me just put 9 minus x minus 2 squared. Okay, and then how will we take care of this square? Take the square root of both sides. Good. So then we would just get y equals, of course it's plus or minus, but we know we're working with the one that's above the x-axis, so we have 9 minus x minus 2 squared. So now we can come back to our area. Limit, our lower limit is going to be what? It looks like -1 and 1, 2, 3, 4, 5. So from -1 to 5, f of x is going to be 9 minus x minus 2 squared, and then we have dx. Okay, so good job there. Alright, and our next example says evaluate the definite integral by regarding it as the area under the graph of a function. So we can evaluate this. So I'll give you a few minutes to write that down. Okay, we're going to learn another method for solving this later, but this says to use area under the graph to help us to evaluate it. So if we try to draw a sketch of this thing, we go, our interval are from -2 to 3, right? Because of lower limit and upper limit. So -2 to 3, and our function, which is our y equals 4. Now if I was to sketch a rough graph of y equals 4, right, that is just a horizontal line there. So we only care about the area in our interval. So basically what we're looking at is this rectangle. So what's the width of this rectangle? 5 units, right? 1, 2, 3, 4. 5 units. And what's the height? 4. So what would be the area? 5 times 4, which is 20 units square. Okay, here's our second one. Evaluate the definite intervals. Same idea as the last one. We have a new function here, so I'll give you a few minutes to sketch this. Okay, I just started sketching this thing. I did some ordered pairs to kind of put some points, and I'm going to draw a rough sketch. And it's going to be very rough, but I'm going to move this out the way now and just put a graph up there. Okay, and I apologize, it's going to kind of go through our problem, but our interval is from -1, so from -1 to 2. So if I was to shade that part in from -1 to 2 and make a figure, we're going to work on finding the area of that. So let me highlight that. So from -1 to just just now forgive my highlighting, it's outside of the lines, but from -1 to 2, if I close that figure in, this portion right here, it's a trapezoid. You can see I just denoted that right here. So we have a trapezoid, and it's kind of like a trapezoid on its side. So it's area of a trapezoid. Let me remind you of your formula. Area of a trapezoid is going to be 1/2 a plus b times the height. So we're going to work on that, a plus b times the height. Let's see, since it's on the side, let's let this side be our a. We'll let that be a. We'll let this side be b. And the height, we'll let the height be this dashed line be our height because it's a trapezoid on its side. If you want to flip it over in your mind, it'll help. So we'll plug that information in now to get this area. A is 10 units, and what was B? 1 unit. B is 1 unit. So we'll have A was 10 units plus B was 1 unit. The height is how many units? So from -1 to here, so that's 1, 2, 3 units. Height is 3 units. Let's calculate that. So it's going to be 1/2, 10 plus 1. So half times 11 times 3. Area is going to be 16.5 units square. This is a trapezoid on its side. Trapezoid on its side. So basically, if I were to flip it, we can see that this was the height. So if you were to rotate it, then it may help you to see that that ends up being the height. Like this. So where this is A, this was B, and the height was that dotted line right here.